Oumuamua, the first visitor to our solar system of many, preparing for future visitors. The thrill of scientific discovery is similar to an unforgettable journey that never fails to leave us awestruck and yields an outcome that continually pushes the boundaries of our imagination. Such was the case of this groundbreaking discovery. On October 19, 2017, the University of Hawaii's Pan-STARRS-1 telescope was scanning the space surrounding our planet, a task made possible by NASA's Near-Earth Object Observations funding. This telescope had a reputation for identifying and tracking asteroids and comets that approached the Earth. On that particular date, the Pan-STARRS observers detected a new object about 33 million kilometers away, which they labeled 1I 2017 U1. What caught their attention was the object's extraordinary speed, clocking in at over 314,000 kilometers per hour, more than 4 times the average speed of objects originating within our solar system. Initially, the question was whether this object was a comet or an asteroid. It didn't display any signs of cometary activity, such as a tail of gas and dust, leading the observers to assume it was an asteroid. However, it was slightly accelerating, a characteristic more commonly associated with comets. The nature of the object would remain a topic of debate for years to come. What was clear to the observers in Hawaii was that they had discovered an interstellar object, ISO, an object that originated from another star system and had entered our solar system. This was a groundbreaking find, as NASA confirmed that 1I 2017 U1 was the first object from another star system to visit our solar system. It's worth noting that astronomers estimate that ISOs pass through our system about once a year, but they're usually too small to detect until Pan-STARRS-1 came along. The discovery of 1I 2017 U1 was significant, not only because of its extraterrestrial origin, but also because it carried valuable information about the composition of distant celestial bodies. The Hawaiian observers fittingly nicknamed it Oumuamua, which means a messenger from afar arriving first in Hawaiian. After the initial observation, the messenger, referred to as Oumuamua, underwent detailed examination by various observatories, including the European Southern Observatory's ESO Very Large Telescope in Chile. The ESO's telescope measured the object's orbit and brightness and shared the images with a team headed by astronomer Karen Meach at the Institute for Astronomy in Hawaii. The team discovered that Oumuamua's brightness fluctuated by a factor of approximately 10 every 7 hours, indicating that the object was spinning or tumbling around its longer axis. This observation led Meach to conclude that Oumuamua had a highly elongated shape, estimated to be around 10 times longer than it was wide, with a complex and convoluted form. Now, before we take a deep dive into what's unusual about the shape, please be sure to subscribe to the Insane Curiosity channel if you haven't already. This helps support the channel and ensures you don't miss out on future high-quality content. What makes the shape of Oumuamua so remarkable? The shape of Oumuamua is one of the most intriguing aspects of this cosmic visitor. Usually, asteroids, meteors, and comets originating in our solar system tend to look like big, chunky boulders, with their width not too dissimilar to their length. However, Oumuamua appeared quite different. Oumuamua had a long cigar-like shape with a length estimated between 100 and 1,000 meters and a maximum width of only 35 meters. In other words, its length was more than 10 times its width, similar to fitting up to 10 football fields along its length and only 2 bowling lanes across its width. Observations by the European Southern Observatory, ESO, also provided clues about the color and composition of Oumuamua. It had a reddish color similar to objects in the outer solar system, suggesting it was a dense, dry object composed primarily of rock and metals. The reddish hue was likely the result of millions of years of exposure to cosmic rays on its surface. Based on its lateral motion observed from Hawaii, the scientific team hypothesized that Oumuamua had been wandering freely across the Milky Way for possibly hundreds of millions of years before encountering our solar system. Undeterred by our curiosity, Oumuamua continued on its trajectory, passing the orbits of Mars, Jupiter, and Saturn before eventually leaving our solar system and heading towards the constellation Pegasus. While the teams in Hawaii and NASA observers speculated that Oumuamua may have originated from the direction of the star Vega in the constellation Lyra, this fact is impossible to prove conclusively. The interstellar traveler's journey through the stars may have begun hundreds or even thousands of millions of years ago when the observable constellations were in different positions. What are the most widely held theories and hypotheses on Oumuamua, and what's the fact? Astronomers were puzzled when they first spotted Oumuamua, the first interstellar object detected passing through our solar system. They had a fairly good model of what the object looked like, a long, cigar-shaped body, and a vague idea of where it was headed, but they had absolutely no clue where it had originated from or exactly what it was. This led to a heated debate among astronomers, with some putting forth rather interesting hypotheses. Initially, the scientists split into two main camps: Team Comet versus Team Asteroid. To understand the debate, it's important to first clarify the basic differences between comets and asteroids. Asteroids are rocky objects smaller than planets that usually orbit the Sun. Comets, on the other hand, are made of ice and dust. When a comet approaches the Sun, the heat causes it to release gases and dust, a process known as outgassing. This outgassing leaves behind a coma, or tail, trailing the comet. The change in speed observed in Oumuamua was compatible with comet-like behavior, as comets have highly elliptical orbits and tend to accelerate drastically as they get closer to the Sun. This lent support to the comet hypothesis. However, there were two significant problems with classifying Oumuamua as a comet. First, the object was observed to accelerate even as it was moving away from the Sun, which is unusual for a comet. The outgassing process may have somehow acted as a propulsion system for this interstellar object. Second, Oumuamua did not appear to have a coma or tail, meaning it was not spewing out gas like a typical comet. So, while Oumuamua may have resembled a long cigar-shaped object, it certainly didn't leave behind a trail of smoke, dust, or gas like a comet would. This puzzling observation led the astronomers to consider other potential explanations for the mysterious interstellar visitor. In 2018, astrophysicist Roman Rafikov from the University of Cambridge proposed a groundbreaking theory about the mysterious Oumuamua project. Published in Quantum magazine, Rafikov's hypothesis suggests that Oumuamua is not a comet or asteroid, but rather a shard from a distant dying star. According to Rafikov, a dying star's immense gravitational pull can shred and rip apart asteroids, moons, and even planets, breaking them into smaller fragments. Oumuamua, he proposes, is one of these fragments sent hurtling through space from a dead star. This theory takes on a terrifying tone when considering the fate of our own solar system. Fun fact, scientists at the University of Warwick believe that this is what will happen to our solar system when the Sun eventually becomes a white dwarf and destroys us. That's a cosmic horror, right? A far-off dying world being destroyed by a dying star? But what if the last inhabitants of that world sent out one last message into space? Alternatively, what if it was a thriving civilization that dispatched a spacecraft to explore the cosmos? Rafikov's theory raises the intriguing possibility that Oumuamua is an artificial object, an extraterrestrial spacecraft visiting our star system. While this idea may seem far-fetched, accredited astronomers have taken it seriously, seeking evidence to support or disprove it. The possibility of alien life sending a message or vessel into the vast expanse of space is a tantalizing one, and Rafikov's theory has sparked a new wave of interest in the search for extraterrestrial life. In January 2018, a team led by Emilio Enriquez from the Department of Astronomy at the University of California, Berkeley, published a paper titled Breakthrough Listen Observations of One-Eye Oumuamua with the GBT. The paper discussed the idea that advanced extraterrestrial civilizations could potentially send probes to other stars for exploration or communication purposes, likely equipped with radio communication technology. Enriquez and his team conducted an observation campaign directed at Oumuamua, the first known interstellar object to pass through our solar system, using the Robert C. Byrd Green Bank Telescope, GBT. The goal was to detect if the cigar-shaped object was the source of radio emissions consistent with a technological source, as Oumuamua presented a unique opportunity to search for extremely weak transmitters, unprecedented in any other SETI experiment. Over 2 weeks, the Berkeley researchers covered the full rotational phase of Oumuamua using the GBT's 4 different receivers, searching for narrowband 3 Hz resolution drifting sinusoids over a drift rate range of plus or minus 2 Hz. Such a narrowband emission, if proven, could have indicated the presence of a transmitter located on the object. However, the research team's preliminary results showed no narrowband radio emissions from the direction of Oumuamua at any rotational phase, suggesting that the object was not a crewed or automated vessel dispatched by an alien civilization. In September 2018, Harvard astronomer Abraham Loeb proposed a novel hypothesis about the mysterious interstellar object Oumuamua that had recently been detected passing through our solar system. Loeb suggested the possibility that Oumuamua could be a technological relic, a piece of advanced equipment from an extraterrestrial civilization now drifting as space junk after losing power over millions of years. Loeb noted that many stars are known to host Earth-like Goldilocks planets, some of which may have developed technology similar to our own. Like us, these civilizations may have sent a multitude of spacecraft and probes into the void of interstellar space, many of which could have degraded into relic-like objects over time. Oumuamua's unusual properties, such as its deviation from a purely gravitational orbit, led Loeb to speculate that it could be an artificial light sail or solar sail, a type of spacecraft that uses the pressure of starlight for propulsion. The authors suggested that as Oumuamua entered the solar system, it may have received a boost from the sun's radiation pressure, which could explain its observed acceleration. However, there is a caveat to this proposal. For radiation pressure to be the cause of Oumuamua's acceleration, it would have needed to be extremely thin, with a tiny mass-to-area ratio. Loeb and Bialy themselves estimated Oumuamua's thickness to be just 3 millimeters, with a radius of 20 meters. These dimensions are inconsistent with the data collected by the Very Large Telescope and other observatories. As the debate over Oumuamua's nature raged on, the mysterious object continued to speed farther and farther away, making it increasingly difficult to conduct additional observations. Ultimately, the exact nature of Oumuamua remained a mystery, at least until more evidence emerged in 2023. What evidence was found? What's the most profound explanation to Oumuamua? On March 22, 2023, the prestigious journal Nature published a comprehensive study conducted by Assistant Professor of Chemistry Jennifer B. Bergner from the University of California, Berkeley, and researcher Daryl Z. Slegman from the Department of Astronomy at Cornell University. The two authors sought to provide a plausible solution to the enigmatic acceleration experienced by Oumuamua, the first known interstellar object to venture into our solar system. According to the researchers, Oumuamua originated as an icy planetesimal. Planetesimals are small celestial bodies composed of rock and/or ice that form within the protoplanetary disks of protostellar systems. These diminutive objects continue to coalesce until a fully fledged planetary system emerges. In our own solar system, small asteroids represent the surviving remnants of planetesimals. Hence, Oumuamua was essentially a massive chunk of ice similar to a comet. In their model, Oumuamua began as an icy planetesimal that underwent irradiation at low temperatures by cosmic rays during its interstellar odyssey and experienced gradual warming during its traversal through the solar system. The researchers' detailed model demonstrated that Oumuamua traveled across the expansive Milky Way, absorbing high-energy cosmic rays emitted by supernova events. These powerful rays may have transformed roughly one-third of the planetesimal's water ice into hydrogen, which remained trapped within the ice. When Oumuamua entered our star system, the sun's radiant heat triggered the release of entrapped hydrogen. The discharge of this gaseous fuel acted as a propellant, favoring the observed acceleration of the interstellar wanderer. Moreover, the release of hydrogen did not leave behind a visible tail, as it possesses a lower mass compared to carbon monoxide and carbon dioxide, the gases typically expelled by comets. In the author's own words, we report that the acceleration of Oumuamua is attributed to the release of entrapped molecular hydrogen that formed through energetic processing of an H2O-rich ice body. Professor Bergner further commented, "We do not need to invoke any extraordinary explanations to account for this behavior." Suddenly, the puzzling speed boost did not appear to be a matter of chance after all, and there was no necessity to invoke technological relics, as captivating and intriguing as that hypothesis might have been. While Oumuamua gained public attention as an intriguing interstellar object, ISO, it is not the only one that has ventured into our solar system. In fact, just 2 years after its discovery, in August 2019, amateur astronomer Gennady Borisov and his self-built telescope found the second ever interstellar wanderer, 2I Borisov. Astronomers believe that advances in technology will enable us to detect up to 7 ISOs passing through our star system each year. However, the challenge with Oumuamuas and Borisovs of the cosmos is that they do not follow a fixed orbit around the Sun, but rather speed through our system before disappearing forever. This transient behavior makes it exceedingly difficult to study them in depth, especially from our Earth-based telescopes. While we could attempt to get closer to these interstellar visitors in the future by using spacecraft like the Comet Interceptor developed by the European Space Agency, a more specialized approach may be warranted. In February 2024, Alan Stern, the principal investigator for NASA's New Horizons mission, published a paper advocating for the creation of a purpose-built robotic craft, an Interstellar Object Explorer, IOE. Stern says a close flyby of an ISO stands as the next logical step in exploring the early history of both our own system and exoplanetary systems. The proposed IOE mission could finally give us a close-up look at the interstellar objects that zip through our solar system, unlocking secrets about planetary formation beyond our own.
What is 2I Borisov? Despite its fancy name, there's a very simple explanation for what 2I Borisov is. It's a comet. I know on the surface of things that doesn't sound very impressive. Why should we care about a comet? But the real thing here isn't that it's a comet. It's that 2I Borisov is a comet that comes from outside our solar system, and it's now here. That makes it an interstellar comet, which is actually rather rare in our part of the galaxy. In fact, it's only the second comet that has done that after the weird object known as Oumuamua. On October 12, 2019, the Hubble Space Telescope was able to get some photos of 2I Borisov, and with it, it came confirmation as to what it was, and how it was different from Oumuamua. Whereas Oumuamua appeared to be a rock, Borisov is really active, more like a normal comet. It's a puzzle why these two are so different, said David Jewett of the University of California, Los Angeles, UCLA, leader of the Hubble team who observed the comet. Obviously, 2I Borisov is special because it doesn't come from our system, but there's more to it than that scientists find interesting. Mainly, this is an object that can help us understand what is going on out there in the universe, and to that end, what's out there and how it relates to our own star system. Though another star system could be quite different from our own, the fact that the comet's properties appear to be very similar to those of the solar system's building blocks is very remarkable, said Amaya Mora-Martin of the Space Telescope Science Institute in Baltimore. Here 1 year, gone the next. The irony of this object is that while it's in our solar system right now and is traveling at an incredible 110,000 miles per hour, it won't stay in our solar system for too long in galactic terms. That is because the comet is flying on a hyperbolic path, which means it's going around the Sun and its gravity in such a way that it's not even slowing down, which makes it even more fascinating because most objects in our solar system get stuck around the Sun unless they have their own propulsion. Anyway, by the middle of 2020, the comet will be zooming past Jupiter and then flying back out into deep space, never to be seen by us again. So for people at NASA and other space agencies around the world, the race is quite literally on to try and learn more about this comet, its composition, and what it is like in all aspects before it's gone. New comets are always unpredictable, said Max Mulcher, another member of the observing team. They sometimes brighten suddenly or even begin to fragment as they are exposed to the intense heat of the Sun for the first time. Hubble is poised to monitor whatever happens next with its superior sensitivity and resolution. Despite the time frame constrictions, the various space teams around the world are trying to secure more time so they can learn more about 2I Borisov before it's too late. Why do comets matter in the grander scale of the universe? All this talk of interstellar objects and hyperbolic paths and all that make this comet sound utterly important, and technically it is, but whatever. But I'm sure you're wondering about why NASA or anyone would care about a comet that not only won't reach Earth, but won't even come close. We're not even likely to get some really good close-up and personal pictures unless we get a lucky shot, right? But here's the thing. Because humanity hasn't mastered space travel yet, and we're not likely to do that anytime soon, we have to rely on probes, satellites, and massive telescopes to try and teach us more about the universe that we ourselves cannot touch and cannot reach. And it's cool to see something like Halley's Comet when it comes around every 70 some odd years or so. We can't learn much from it. What's more, most of the comets that do come to Earth are from within our own solar system, including the asteroid belt that separates Mars and Jupiter. While it's cool to get comet or asteroid or meteorite data when it comes to our planet, that can only teach us about the areas of our own system, not what lies beyond it. Whereas things like 2I Borisov is something that can help us look into the future of space travel as well as paint a picture of what the universe is like out there beyond our own solar system. And as many sci-fi, TV shows, and movies have shown, the ultimate goal of humanity is to go and embrace the stars that are beyond our own borders. Every comet or object like 2I Borisov that comes even remotely close to us is a chance for us to learn. And that's why many people jump at the chance to study things like this. What is 2I Borisov like? So despite the fact that scientists are hoping to get more information on 2I Borisov in the upcoming months or years, we do have some indication of what it is and what it isn't, right? Well, yes, we do. As noted, we know it's a comet, and that's an important thing because it helped visually define the interstellar object. For example, we first knew it was a comet because of the coma. For those who don't know, the coma is the fuzzy part of the comet that you see as it moves through space, which is actually activated when the rock passes by a sun. It causes the comet to slightly melt and create the fuzzy nature that you see. As for the size of the comet, that's a bit trickier, because as the comet has moved through space, the estimates of how big it was or wasn't has changed, based on the technology that was used to observe it. In the end, we believe that the diameter of the nucleus of the comet is about 1.4 and 6.6 kilometers in diameter, which is pretty big considering. For all intents and purposes, it's a comet like you would expect to find in the universe. It just so happens that this one is racing through star systems and it happened to pass by us. How did we discover 2I Borisov? So everyone involved in space programs are marveling at this very special interstellar object. But where and when did we exactly discover that this thing was even close to us? Well, that would be on August 30th, 2019 by amateur astronomer Gennady Borisov at his personal observatory, Margot. Yes, some people have their own personal observatories. Totally not jealous. Oh, and the telescope that he used to find the comet? Yeah, he made that himself too. Still not jealous at all. Here's the discovery in the words of Borisov himself. I observed it on August 29th, but it was August 30th Greenwich time. I saw a moving object in the frame. It moved in a direction that was slightly different from that of main asteroids. I measured its coordinates and consulted the Minor Planet Center database. Turned out it was a new object. Then I measured the near-Earth object rating. It is calculated from various parameters, and it turned out to be 100%. In other words, dangerous. In such cases, I must immediately post the parameters to the World Web page for confirmation of dangerous asteroids. I posted it and wrote that the object was diffuse and that it was not an asteroid but a comet. As you can see, it was a very big discovery, and that's why the asteroid was named after him, because it really was his discovery. And how cool is that? That this guy who made his own telescope in his own observatory found an interstellar object before NASA and all the other space programs. Kind of motivates you to try your own kind of stuff, huh? After that, the other space agencies grabbed onto it and started doing the research that traced its origins and more, as well how it's connected to another object in space. The major differences between 2I Borisov and Oumuamua. With both Oumuamua and 2I Borisov, we have a pair of interstellar objects that have gotten a lot of attention in the world today. But as scientists continue to study the latter, the former becomes even odder in their eyes. So much so that they're kind of relieved that 2I Borisov is so normal compared to the long, thin toothpick like Oumuamua. It's kind of relieving that finally we have something that meets our expectations, said study co-author Michael Dreyhaus, an astronomer at the Jagiellonian University in Krakow, Poland. Now we really can be absolutely sure that Oumuamua was one weird object. Here's another take on the differences. Whereas Oumuamua looked like a bare rock, Borisov is really active, more like a normal comet. David Jewett of UCLA, leader of the Hubble team who observed the comet, said in a statement, "It's a puzzle why these two are so different. It is odd, isn't it? Theoretically speaking, they should be so different as they're both comets in one way or another, yet one has a comma, the other doesn't. One is round, one is long and thin, one is on a constant trajectory, and the other is going faster and faster as it travels through space. What is the deal here? Why is it that these objects are so different, yet they're technically the same thing? No one knows, and that's what makes it all the stranger."
The third interstellar object visiting us has been officially discovered. Just a few years ago, humanity was amazed by the arrival of the first two known interstellar objects, Oumuamua and 2I Borisov. Now a third traveler from the depths of space has entered the scene, C2025N1, also called Atlas or A11PL3Z. What secrets does this new visitor from another star system hide? Could it reveal clues about the formation of distant worlds or the mysteries of the universe? All about 3I Atlas. The third interstellar object discovered, officially designated C2025N1 Atlas and known initially as A11PL3Z, has captured the attention of astronomers worldwide as another visitor from deep space. This object was detected on July 2, 2025 by the Atlas Asteroid Terrestrial Impact Last Alert System telescope system, a NASA-funded program operated by the University of Hawaii that specializes in tracking near-Earth asteroids. Atlas is comprised of several observation stations located across different Hawaiian islands, as well as in South Africa and Chile, enabling it to monitor the entire night sky every other night for fast-moving objects. The discovery of C2025N1 was made possible by images taken with the Atlas telescope, located at Haleakala on the island of Maui, Hawaii. This telescope is equipped with a wide-field camera that enables the capture of faint and fast-moving objects. The images revealed a point of light with a swift motion and a trajectory that did not match any known orbit of solar system objects. By analyzing the data, the Atlas team confirmed that the object had a hyperbolic orbit, meaning its speed exceeded the escape velocity of the solar system, an unequivocal signal of interstellar origin. The finding was promptly communicated to the Minor Planet Center, the international body responsible for centralizing observations of comets and asteroids. After confirming additional sightings from other observatories in Spain, Chile, and Australia, it was determined that the object would follow a trajectory that would take it through the inner solar system over the next few months, before re-entering interstellar space. According to preliminary calculations, C2025N1 is moving at a speed relative to the Sun of about 118,000 miles per hour, a breakneck speed that matches the typical speed of interstellar objects observed to date. Its estimated size ranges from 0.6 to 1.2 miles in diameter, with a nucleus that could be comparable to that of a small or medium-sized comet. Initial observations with the Canada-France-Hawaii telescope and the Very Large Telescope in Chile suggest that it shows a faint coma, a cloud of gas and dust indicating that it is more similar to 2I Borisov than Oumuamua. The credit for the discovery primarily goes to astronomer Larry Deneau, one of the co-principal investigators of the Atlas project, who confirmed the images and led the analysis that enabled the identification of the object's hyperbolic trajectory. However, the finding was the result of the joint work of an international team of astronomers who coordinated efforts to follow the object in the hours and days after its detection, which was crucial to determining its origin and predicting its passage through the solar system. As for its brightness, early estimates indicate an absolute magnitude of approximately plus 18, which means it can only be observed with large telescopes. As it approaches its perihelion, the closest point to the Sun, it is expected to reach an apparent magnitude of plus 12 or plus 13, insufficient to see it with the naked eye, but within the reach of medium-sized telescopes of experienced amateurs. Is it a danger to Earth? After the few first days of monitoring, astronomers from around the world put their data together to calculate the trajectory of C-2025N1 accurately. The observations were centralized at the Minor Planet Center, which coordinated the collection of astrometric measurements from observatories in Hawaii, Spain, Chile, South Africa, and Australia. The orbital calculations refined with the first weeks of data confirmed that the object's orbit is hyperbolic, with an eccentricity greater than 1.15, which guarantees that its passage through the solar system is unique. It will never return. According to the latest predictions, C-2025N1 will reach its perihelion, the point of closest proximity to the Sun, on December 7, 2025, when it will pass approximately 160 million miles from the Sun, just a little beyond the average distance between the Earth and the Sun, 1.7 astronomical units. At that time, the object will be at its most active and brightest, providing astronomers with the best opportunity to study its coma and tail, should it exhibit more intense cometary activity. The calculated trajectory shows that C-2025N1 will move from the constellation Sagittarius towards the northern celestial hemisphere, visually crossing the constellations of Eagle, Dolphin, and Pegasus in the night sky. However, its passage will be swift. As it approaches perihelion, its speed relative to the Sun will increase to almost 160,000 miles per hour, causing it to move several degrees per day in the sky, a movement that telescopes will have to follow carefully. As for its minimum distance from Earth, calculations indicate that it will occur on December 2, 2025, when the object will pass within about 210 million miles of our planet, i.e. more than twice the average distance between Earth and the Sun. This separation ensures that there is no risk of impact, therefore you don't need to worry or be alarmed. The planet it will come closest to will be Mars. On November 20th, 2025, C-2025N1 will pass just over 160 million miles from the red planet. While that distance is still huge, space agencies such as ESA and NASA are already preparing observations from orbiters on Mars to get a privileged vantage point of an object that could prove unique data on its surface, activity, and composition from a perspective other than Earth's. For now, the world's largest telescopes, such as the Very Large Telescope, VLT, in Chile and the Gran Telescopio Canarias in Spain, are scheduling observing sessions for when the object reaches perihelion and it is at its most brilliant apparent brightness. It will be on those days that the most detailed spectra and the most valuable data on its composition and structure can be obtained. What is it? One of the aspects that most intrigues astronomers about 3I Atlas is its composition, as each interstellar object discovered so far has presented unique characteristics that challenge our ideas about the materials that make up planetary systems beyond the Sun. In the case of Oumuamua, no clear sign of cometary activity was detected, leading to speculation about a rocky or even metallic origin. In contrast, 2I Borisov showed traditional cometary behavior with a coma of gas and dust, revealing a composition rich in ices and organic compounds similar to Kuiper Belt comets. From the first days of monitoring C-2025N1, several telescopes began to analyze its light to unravel the elements that compose it. Observations made with the Keck telescope in Hawaii and the VLT in Chile detected a faint but unmistakable development of coma, a cloud of gas and dust that forms when the sun's heat sublimates the ices on the surface of the object. This detail confirms that C2025N1 is an interstellar comet, making it more similar to 2I Borisov than to Oumuamua. The spectra obtained so far show characteristic emission lines of compounds such as cyanogen and diatomic carbon, two typical components in comets known in the solar system. Water in vapor form has also been detected from near-infrared emission band analysis, suggesting that, like local comets, C2025N1 possesses water ices that sublimate as they approach the Sun. This is a fascinating clue that the processes of comet formation in other star systems may be strikingly similar to our own. Regarding its shape, observations made by the Subaru telescope and the Hubble indicate that it has an approximate diameter of 15 miles. However, given its distance and the small angular size it exhibits in telescopes, these calculations remain estimates that are subject to revision as the object approaches the Sun and the images improve. The elongated shape could be due to partial fragmentation suffered in the past, a phenomena also suspected in some local comets, such as 67P Churyumov-Gerasimenko. The combination of its physical and spectral characteristics leads astronomers to classify C2025N1 as a comet composed mainly of water ices, carbon monoxide, and carbon dioxide, mixed with silicates and complex organic compounds. In short, a comet strikingly identical to those in our own solar system. This is important because if this comet contains the building blocks of prebiotic chemistry, it would mean that the dispersal of molecules essential for life between star systems could be somewhat more common than we thought. The confirmation of their cometary nature strengthens the hypothesis that many interstellar objects could be comets ejected during the formation of the planetary system. This process also occurred in the solar system 4.6 billion years ago. This reinforces the idea that ices and organic compounds can survive in interstellar space for millions of years and arrive intact in other systems, seeding the possibility that these materials travel between stars. Could it be that the molecules that gave rise to life on our planet could have come from another solar system through a comet like this one? Let us know what you think in the comments. Where does it come from? The question everyone asks when an interstellar object crosses the solar system is, where exactly did it come from? Thanks to precise measurements of its trajectory, astronomers have been able to trace C2025N1's possible path back in time, looking for the region of the sky from which it came. Current calculations indicate that this interstellar comet appears to come from the direction of the constellation Lyra, a sector of the sky rich in stars and star-forming regions. This detail is fascinating as it suggests that C2025N1 could have been ejected from a young planetary system that formed in that area hundreds of millions of years ago. By analyzing the object's velocity and comparing it to the dynamics of our galaxy, astronomers estimate that C2025N1 has been wandering through interstellar space for at least 800 million years. This means that it left its original system when Earth was just beginning to host multicellular life forms in the oceans, and that since then, it has traveled aimlessly through the void until chance brought it to a brief encounter with our Sun. After passing through the solar system, it is estimated that it will follow a new trajectory towards the halo of the Milky Way, moving with enough speed to escape even the combined gravitational pull of the Sun and the planets. One of the most widely accepted theories about the origin of objects like this is that they were ejected during the first millions of years of life of their star system, when giant planets such as Jupiter or Saturn were forming and their strong gravitational fields acted as catapults for small bodies such as comets or asteroids. This process also occurred in our own solar system, where trillions of comets are thought to have been launched into the Oort cloud or ejected into interstellar space. C2025N1 could be one of those exiles from another star, a witness to the violent beginnings of a distant planetary system. Of course, not all scientists agree on a single scenario. Some researchers raise the possibility that objects like C2025N1 not only originate from known planetary systems, but could also form directly in giant molecular clouds before the stars ignite, roaming the galaxy as primordial fragments. Others suggest that gravitational interactions in star clusters, where stars are born close together, could favor the mass ejection of comets and asteroids, creating veritable showers of interstellar objects that travel over eons. This leads us to reflect on disturbing questions. What would have happened if C2025N1 had a trajectory that took it directly to Earth? 3I Atlas travels at 118,000 miles per hour. If it were on a collision course with Earth, it would impact our planet in mid-October of this year. If we consider that it was discovered on July 1st, it would mean that humanity would only have 3 months to deflect it, destroy it, or make any maneuver to avoid that collision. Let's remember that the meteorite that ended the age of the dinosaurs was only about 12 kilometers in diameter. This comet measures 24 kilometers in diameter, exactly twice that size. If it were to go to Earth and we did nothing, it would wipe out all traces of life on the planet. The movie Armageddon from 1998 would become a reality. Fortunately, 3I Atlas does not pose a danger to the Earth, as its closest approach to our planet will be at a greater distance than the Earth's distance from the Sun. However, this serves as a reminder that life on Earth could end at any moment due to one of these extrasolar visitors. The study of these objects is not only essential for understanding how planetary systems formed, but also for improving our ability to detect early and potential impacts. Each interstellar object we discover is an opportunity to refine our orbital observation and modeling techniques, taking us one step closer to being able to detect in time any potential collision course that one of these travelers might have. Thanks for watching. If you liked the video, then you should check out our interstellar videos on the end screens.